I'm Mr. Spudik. Welcome back. Today we're going to be talking about pop flies. Okay, so this is what we're looking at right here. That. Okay, something's going straight up, coming straight back down. We're going to have the picture that will be spread out so we can look at the trip going up and coming back down. But we're going to talk about gravity again, but this time with a ball that's going straight up and coming straight back down. All right? Okay, so let's look at this picture here. We have points A, B, C, D, and E. They are not drawn to scale. They're just going to be drawn. I'm just trying to fit them in there. But the idea is that even though you see it spread out, or even though you see it going like this, really it's going straight up and down. And we want to look at the trip going up, trip going down. So we see an initial velocity to start with of 49 meters per second. Okay, so right here we got 49 meters per second. That'll be our starting velocity. Let's go to point B. Okay, point B, we're saying that it's going to be after 1 second, that's the time. Okay, so after 1 second, that's where the point is. What do you think is going to be the acceleration? The acceleration is always going to be gravity. Always, always, always. So we know that the acceleration is always negative 9.8 meters per second squared there. Okay, and we want to figure out our velocity at this point. So let's do that first. Let's pick a velocity, or let's solve for velocity. So I'm really going to look for V final here, where my initial velocity is going to be 49. Okay, so we always like to list our givens. So if I want to look at my givens, I have an initial velocity of 49 meters per second. I have my acceleration, which is gravity, negative 9.8 meters per second squared. Okay, we have time is equal to 1 second. And we're looking for final velocity at that point. And it's not really the final velocity, but it's going to be the velocity at that point, which we will say final velocity. That's what we're looking for. So that's our question mark. Okay? So now we pick our equation. And your equations might look different than what I teach in my class always. But the equation that will work best is going to be V final is equal to V initial plus AT, acceleration times time. We can plug in our values. We have a 49 for my initial velocity, negative 9.8, and a time of 1. So we get that, plug in our calculator, and we get 39.2 meters per second as the velocity at this point right here, at point B. All right? Now, the reason we do this calculation is I want you to think of another way of what gravity is, okay? Just to help you wrap your head around and conceptualize it. Another way to think of it is velocity. Whatever something's in the air, whenever something's in the air, it will have a velocity to it. Gravity will always take away 9.8 after each second. Okay, I'm not saying this is the best way to calculate it, but just as another way to think about it and to picture of it. So if this ball, let's say this ball is going up like in the picture, right? The ball is going up, it has a positive velocity. Well, gravity, as soon as it's in the air, after every second, gravity is going to subtract 9.8 meters per second from its velocity. So if it had a velocity of 49 meters per second, 1 second later, you can subtract it away, and we had our 39.2. Okay? Also, when the ball is coming back down, all right, now the ball is coming back down, it has a negative velocity. We're still going to subtract 9.8, all right? And so if we had a negative velocity, we're just going to subtract and make a bigger negative number and bigger negative velocity after a second. If we're going back up again, when it's going back up, we're just subtracting 9.8 to make a smaller negative or smaller velocity, but positive. Okay? So that's one way to think of it. The reason I say that, the reason I want you to think of it that way is sometimes students think about the path going up and the path going down, and they think gravity is doing something different because they think in terms of speeding up or slowing down, right? Some students will say, well, it's going up right now and gravity is going to make it slow down. But then when it's falling back down, it's going to make it speed up. So you told me acceleration was negative, but is it positive when it's coming back down? No. It's just that you're subtracting 9.8 from whatever velocity you have after a second. Now, it's not like we deal with whole seconds and you want to use the equations, but it's just to help you understand. whatever the velocity is, after another second, you will subtract 9.8 from that velocity and get your new velocity. Okay? All right. So, V final, in this case, we figured out was 39.2 meters per second. All right? Now, let's look at the peak. Okay? Point C is going to be the peak. All right? What is the peak when something goes straight up and comes straight down? Okay? The peak at the top, the velocity is going to be 0. Okay? At any time something goes up and comes back down, at the highest point, the velocity will be 0. Okay? So let's fill that in. Velocity here is 0 meters per second. Always, anytime something goes up and comes back down, at the highest point, the velocity for a split second in time is going to be 0. All right? Another way to think of it is this. An instant before it hits the peak, it's going up. That's a positive velocity. An instant after, it's going down. That's a negative velocity. So if you think about, say, a number line, right? If you go from a positive number to a negative number, you have to go through 0. Now that doesn't mean that the velocity, that doesn't mean the ball is going to just sit there and wait and not move at all. Okay, it's just that for that split second of time, the velocity is 0 before it starts coming back down again. Okay, so we have the velocity at the peak of 0. Now, I always ask students the next question, and I'll tell you, it is always the question, it's probably the most common mistake students are going to make with falling objects. All right, and sometimes the most common, I just know people are going to get this answer wrong. Probably one of the bigger mistakes you'll see all year. Okay, and the question is this. I would have 2 questions on my test. And the first question I would say is, what is the velocity at the peak? And everyone would say, oh, I know this one. Velocity is 0. Velocity at the peak is 0. And then I say, well, what's the acceleration at the peak? So right now, I want you to think about this. And don't answer it. Don't, not yet. Okay, right now, I want you to think about it. What is the acceleration going to be at the peak? Okay, what do we get? If you said 0, you're wrong. That's okay. All right. But as the most common mistake people are going to make, at the peak, yes, the velocity is 0. For a split second in time, the velocity is 0. However, gravity does not stop pulling. Okay. It's not that it says, oh, it stopped moving here, so there's no acceleration. And this is where students get confused between velocity and acceleration. Okay. Velocity is talking about how fast you're going at every instant in time. But acceleration, gravity will always, always, always pull with negative 9.8. Always. Okay? And another way, again, think about this before and after idea, right? An instant before the velocity was 0, it was a positive velocity. An instant after it's 0, it's a negative velocity. So that velocity is always constantly changing, no matter what. Okay? Gravity does not stop pulling. Gravity will never change. The velocities are always changing. Even if the velocity at one instant in time is 0, the acceleration is still going to be negative 9.8. All right. How about we solve for time at the peak? Because this is a good question to ask about what's the velocity of the peak going to be. So let me erase what I have on my board here. Okay. And let's clean it up and get something else on here. What can I erase? Right here. Okay. I'll erase what I got and clean it up for you. Okay, so here we go. So, what is the time going to be to reach the peak? Well, let's list our givens. Okay, so far we know the acceleration is always, always, always negative 9.8 meters per second squared. We can write that down. We know that the velocity at the peak is 0, which I will say V final. Okay, V final is 0 meters per second. My initial velocity is the velocity from time equals 0, the very, very beginning, which is the 49 meters per second. So V initial is 49 meters per second. And I want to know time, so I'm going to write that in my givens. T equals question mark. Okay, again, I can pick my equation, but the equation that jumps out at me is VF equals VI plus AT. All right, I do my algebra. I'm going to move around, and so I'm going to subtract, whoops, I did the wrong spot, subtract VI from both sides. So far, so good. I have VF minus VI is equal to AT. Now I'm going to divide both sides by A. So the A's can't cross out. And I have time is equal to VF minus VI divided by A. My final velocity was 0. My initial was 49. My acceleration was negative 9.8. All right, I divide that out, and I should get a positive time because you're not going backwards in time. Okay, so I get a time of 5 seconds. All right? Okay, so my time at the peak, it took 5 seconds. Now, that's not something, that's just a little practicing doing your calculation. Don't sweat so much that stuff right now. I want you to get the concepts and understand that, but it's a good little practice in practicing our formulas and listing our givens. Okay, so now let's talk about point D. Point D is the same height as point B. So point D and point B are the same point, same height, but B was when it was coming up. D was when it's coming back down. Okay, so our velocity will be the same velocity at the same height if it's going up or coming down, except negative. So if the velocity at point B was 39.2, then the velocity at point D will be negative 39.2. Remember, negative just means direction, right? So if it was going up, it had a positive velocity. Coming back down, it should have a negative velocity. So it's going to be a negative 39.2. What's the acceleration going to be? Always, 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 negative 9.8 meters per second squared. Okay? All right, now, this key concept I want you to understand, that no matter what, the velocity going up and the velocity going back down at the same height will be the same velocity but negative. So if it's going up, whatever the velocity here is, when it comes back down, it will be the same number but negative. Okay? Here is kind of a morbid explanation of it, but when back, this is dating me, but going back to after the first Gulf War. The first Gulf War, Kuwait was invaded by Iraq. Okay, and so what happened was Kuwait gets invaded by Iraq. U.S. and other forces come in and push Iraq out of Kuwait. And I remember hearing about reports of people celebrating in the streets, shooting guns into the air. Okay, but then the reason I heard those reports was because there were other reports of people miles away getting hit by these stray bullets coming back down, and they're coming back down with the same exact velocity they were leaving with. Okay, it doesn't just happen in the Middle East. The United States is the same thing. There's always reports of that same problem where people are shooting guns in the air, okay, and they're coming back down a couple miles down the road, and they're hitting people. Stray bullets are hitting people, because the bullet left with whatever velocity. When it comes back down, it will have the same exact velocity, but negative. Okay? Again, it's a gruesome thing, but that's a reminder of why we have velocity coming back down. Okay. Now, let's finish the bottom part. So at point E, whenever you do a pop fly and something's about to hit, don't assume that it hit the ground and the velocity is 0. Okay? Anytime a teacher asks a question, they're really going to say, at the instant before it hits. So don't just assume the velocity is 0 because, oh, it doesn't hit the ground there. Don't do that. Okay? But let's see what we can put. So the acceleration is still going to be negative 9.8 meters per second squared. Always, always, always. And our velocity at E will be the same as the velocity as A, but negative. So negative 49 meters per second. Okay? All right, let's move on. Whenever you solve a problem, the key will be this. If you ever have a pop fly problem, you are just going to split the trip in half. Okay? Anytime something goes up and comes back down, those trips, the up trip and the down trip, will be symmetrical. So, if you are ever given a problem where a ball went up and came back down in 10 seconds, what you always want to do is just split the trip in half and only look at either the trip going up or the trip going down. You can decide, okay? But you're going to split that trip in half, and if it was 10 seconds going up and down, just make your time 5, okay? So the instant here, what I would do is if I had a problem in a pop fly and I want to know, hey, how far down does the ball fall? Well, I would look at half the trip. And let's say that I decided that my total time was 10 seconds. All right. I would look at just this trip falling down, and I would say my time is only 5 seconds. Okay, and then I could solve all the other pieces. Well, my initial velocity now is going to be 0 because we know the velocity is at the peak is 0. So that helps too when you split the trip in half. That also helps because you know a little bit more information. You know the velocity at the peak, and you can either make that the initial velocity like I did here, or you can make it the final velocity and have the trip going up. Okay, so that is what I'll always tell you to do. Whenever you have a pop fly problem, split the trip in half and only look at half the trip, and then you can also put in a velocity of 0 at the top. Okay, that's about it here. Thanks so much for watching, and I'll see you in another video.